So we are going to study about Stark effect. We are going to study about Stark effect. What is Stark effect? Stark, sorry, Stark. What is Stark effect? Let's look at what is Stark effect. And we have and Zeeman effect. Zeeman effect. Let's look at what is Stark effect and Zeeman effect. Up whenever students say about that ki Stark effect and Zeeman effect is not a part of the syllabus, I just laugh at them because the Stark effect and Zeeman effect uh, are the drawbacks of both atomic theory. A Stark effect and Zeeman effect, if you want to understand generally, they are series of series of spectral series of magnetic series of magnetic and electrical field lines. Okay, so Stark effect and Zeeman effect are what? They are the series of magnetic. So it is the splitting of the spectral lines. Okay, it is the splitting of the spectral lines. So we can understand it with this. It is Stark effect and Zeeman effect. So these are the splitting of spectral field lines. This is the splitting of Stark effect is the splitting of spectral electrical field lines. Electrical spectral electrical field lines. Okay, this is called as Stark effect. This is called as Stark effect. Look here, this is called as Stark effect. This is called as Stark effect. This is Stark effect. I hope it is clear now what is Stark effect is. Now another one is Zeeman effect. Zeeman effect is the splitting of the spectral magnetic field lines. Splitting of the spectral magnetic field lines is called as the Zeeman effect. Now, so these are these are two examples. What you have asked me in the doubt, that is Stark effect and Zeeman effect. Stark effect and Zeeman effect. Okay, this is Stark effect and the Zeeman effect. These are series of magnetic and spectral field lines. Stark effect and Zeeman effect. Another one is you asked me about resonance. Resonance is what? What is resonance is? What resonance is about? Uh, let's look at what resonance is about. Resonance, we can understand it. Suppose what is happening here in this case, resonance is the delocalization of pi electrons. Pi electrons means, let's understand what pi electron is. Let's understand what pi electron is. We have to understand about resonance. Okay, we have to understand about what resonance is. So let's look at what resonance is about. And I told you that it is delocalization of pi electrons. So suppose we have, what is pi electron? Pi electron is formed when there is a double bond between two of the atoms. Suppose there is carbon and carbon atom, and when it forms a double bond between two of the atom, one bond is sigma bond and another is pi bond. And delocalization of this particular bond is called as resonance, is regarded as resonance. So in your example in your book, they have shown you about one of the resonance you have been given in your NCRT book, and one more resonance which I taught you in the class was of CO3 to minus ion, carbonate ion. Okay, so let's look at what carbonate ion resonance is about. Can we do this? Can we draw a bond between, this is uh, can we draw a bond between carbon atom and the oxygen atom? Here one oxygen atom, here one oxygen atom. And we know that oxygen atom do have how many electrons? Six electrons. Here oxygen atom are having how many electrons? 6 electrons. So two are being shared. Is it visible? I think yes, it is visible. And here oxygen atom are having 1 2 3 4 5 5. Okay, we can write it like this. 5 5, and we can have 6 electron, 1 2 3 4 5, 1 2 3 4 5 and 6 electron we have, and one negative charge. Here we have one negative charge. Okay, similarly 1 2 3 4 5 6 and one negative charge. Okay, so this is all about it. And what is happening, it is here we will have delocalization of pi electrons. अब pi electrons कौन कौन से होते हैं? सिग्मा, ये जो electrons होते हैं, these are pi bond, these are pi bonds. ठीक है, so with delocalization will occur, and in the process let's see what happens. Carbon, again oxygen, and we will have here bonds. So what will happen, this there will be the movement of the electron. ये जो particular electron आप देख पा रहे हैं, which is visible to you, this particular electron will shift this side, मतलब whole pair will shift this side. When this whole pair will shift this side, what will happen, here we have a double bond, here we have a double bond. I am mentioning it with different color so that you all does not get confused regarding 1 2 number of electrons and 3 4 number of electrons. 4, earlier we used to have 5 6 electrons. Now we have a double bond between them. Now we have a double bond between them, and the double bond is being shared, so one of the pair of the electron is gone. Okay, so this electron pair is moved, and when there is a shifting of electrons, so what will happen, here also you will have a double bond, 1 2 single bond, sorry, 3 4, and this will have a complete electron 5 6 negative charge. Okay, and again there is a delocalization occurring, and this time the delocalization occurs. What happens, again this particular pi bond shift itself, and when this pi bond shift itself, so what happens, we can again get this kind of a structure of carbonate, C O O double bond O. Okay, O double bond O, and here we have double bond, yes, so double bond is 2 electrons, and this is a negative charge. This is not a negative charge, this is a electron here, and we will have electrons here now 1 2 3 4. Okay, and we have 1 2 4 5 6 electron, and he will have a negative charge here. This particular delocalization which is taking place is called as resonance. This is first, this is second, and this is third. This is third. Three resonating structures are possible in this case. So this is called as resonance in terms of carbonate ion. Now one more example is given in terms of ozone. Others, your next doubt was related to bond order or bond angle, I guess. Bond angle, right? So here it is another part. This is bond angle. I told you what bond angle is. Bond angle, if you would have seen my notes, you would have understood what bond angle is all about. What bond angle is all about. So bond angle is, suppose, let's see, it is the distance, sorry, it is not the distance, it is the measurement of arc, measurement of arc formed by two bonded atoms, two bonded electrons. For example, let's see an example. two bonded electrons के बीच का जो distance है उसको क्या कहते हैं? Bonded electrons के बीच इसको कहते हैं bond angle. Let's see an example. Take me. I have taken oxygen, as I mentioned, and I have taken hydrogen here. Okay, and the distance between this, actually they have two lone pair of the electrons with them, and these two, because of these two lone pair, it from 104.5 degree, 5 degree of the 5 degree of the angle, 5 degree of the angle between them, and this is called as bond angle, and this is called as bond, and this measurement is called as bond angle. And every angle have different bond, every element have different bond angles. We have seen in Weissenberg theory itself. ठीक है, हमने Weissenberg theory में भी देखा था कि हर एक एंगल के different हर एक elements का different bond angle है. Now we have another part. We were talking about bond angles. Now we can talk about another bond type of bond angle, that is BeCl2. BeCl2. ठीक है, and a bond between them is 180 degree. This is the measurement of arc formed by two of the bonded atoms, या two of the bonded electrons. इसको कहते हैं क्या? इसको कहते हैं bond angle. So this is all about you wanted to know, wanted to study today. And apart from your numericals video, you have to practice the numericals a lot. Not only you will be able to solve the numericals, and don't miss out any of the numericals. I hope it's clear. Even easier part of the numerical you should not miss. Then there is another topic you asked about, the mole fraction. Mole fraction. Let's look at mole fraction. This we have studied in month of June and too many times. It is denoted by chi. Eta. इसको कहीं eta भी बोलते हैं, इसको chi भी बोलते हैं, eta. It is denoted by eta. Let's see. It is the number of moles of. Suppose we have two components. We have two component A and component B. So mole fraction A component in terms of A is number of moles of A and A divided by Na plus NB. इसको क्या कहेंगे? मोल फ्रैक्शन, chi. ठीक है. Then we have chi B is equal to mole fraction of NB upon Na plus NB, and chi A, eta A whatever it is equal to, eta B is equal to 1. दोनों की इक्वल क्या होता है? मोल फ्रैक्शन. दोनों का सम होता है 1. This is what we have studied. Well, okay. And empirical and molecular formula are also important. Stoichiometry, I have to tell you, but I will tell you that you can just read it in stoichiometry and solve it, but I will tell you, I will try and tell you. थोड़ा सा बड़ा हो जाएगा वीडियो. Empirical and molecular formula. Let's look at what is empirical formula. Empirical formula, it is the empirical formula of a compound. Let's look at what empirical formula is. Empirical formula. Let's look at what empirical formula is about. Empirical formula is about. So let's talk about empirical formula. It is the simplest whole number ratio. It is the simplest whole number ratio. Simplest whole number ratio. The simplest whole number ratio pen is not working now. It is the simplest whole number ratio of atoms present in a कंपाउंड. एक कंपाउंड में जो नंबर ऑफ रेशियोज होते हैं उसका जो एलिमेंट एटम्स होते हैं उसका सबसे सिंपलेस्ट होल नंबर उसको क्या कहते हैं एम्पेरिकल फॉर्मूला. वंस अगेन लुक एट दिस डेफिनेशन. इट एम्पेरिकल फॉर्मूला मीन्स इट इज़ द सिंपलेस्ट होल नंबर रेशियो ऑफ एटम प्रेजेंट इन ए कंपाउंड. एक कंपाउंड में रिप्रेजेंट हो तो उसको कहते हैं क्या, सिंपलेस्ट होल नंबर रेशियो. अब उसकी सिंपलेस्ट होल फॉर एग्जाम्पल लेट्स टॉक एग्जाम्पल. फॉर एग्जाम्पल इसकी बात करें कि फॉर एग्जाम्पल हम एग्जाम्पल पे जाते हैं. C12H22O11 इसका सिंपलेस्ट होल नंबर रेशियो हो सकता है. लेट्स लुक एट एग्जाम्पल चेंज करते हैं. इसका सबसे सिंपल एग्जाम्पल से लेते हैं. लेट्स लुक एट विद द इजीएस्ट ऑफ द एग्जाम्पल एज गिवन in the book itself. C6H12O6 है. C6H12O6 इसका सिंपलेस्ट होल नंबर रेशियो निकालना है. इसका सिंपलेस्ट होल नंबर 6 1 6 6 2 12 and 6 1 6. So what we get is CH2O. This is called as empirical formula of a compound. It is the simplest whole number ratio of a particular atoms present in a compound. This is called as empirical formula. इसी को empirical formula